Yes. Good evening to all the participants. Let us start the day 11 session on molecular phylogeny. So, whatever left out, majorly we left out hands-on experience with phylogenetic tools and bootstrapping and other concepts. We'll be discussing it on today. Okay, so before going to day 11 on molecular phylogeny, this is the last session for molecular phylogeny. If you have any doubts, you can ask me at present. Do you have any doubts in the last 10 sessions? So if you see, I just recap what exactly I have completed for the past 2 weeks. The first week we discussed on biological databases. For the first 4 sessions, we discussed on biological databases. And then the next 4 sessions are about the sequence analysis. And we have completed 2 sessions in molecular phylogeny. So we'll be computing the last session of molecular phylogeny on today. On tomorrow onwards, we discuss on macromolecular structural analysis. We see how to predict the gene, how to predict the protein structures, how to predict the peptide structures. Okay, so we see even the micromolecules. Okay, because for the project we should know how the structures are determined. So all these structures we'll be discussing from tomorrow onwards. How to predict, how to validate the structure, all these things, okay, and how to visualize the structure. So all this information we'll be discussing in the next 4 sessions, okay. So now let us complete the left out concepts in phylogeny. Okay, if you have any doubts, I can type the same in the chat box so that I can reteach. Okay, I can teach you once again. If no doubts, I can just discuss the last session topics. Can participants can unmute and answer, or you can type the answers in the chat box. What exactly did we discuss in the last session? Yeah, just we had 2 days gap, Saturday and Sunday. You have sufficient time to watch even the recorded videos, isn't it? And even you can practice yourself. The Saturday, Sunday is meant for practice. Okay, you had a gap, but utilize well. Maximum parsimony, very good. We discussed about character-based methods. First time you have interacted, even you can interact from up to the last session. Good. So as usual, Shivan is answered test likelihood, maximum likelihood. Good. What else? Other than maximum parsimony and maximum parsimony and maximum likelihood or character-based methods. And whatever she is answering is distance-based methods. That is UPGMA. Can someone expand UPGMA? So this is the first distance-based method you have mentioned. Can someone expand UPGME? Only 2 participants are interacting from the beginning. How about the others? What is the expansion of UPGME? So it is based on the algorithm steps, isn't it? Based very good. Unweighted pair group method of arithmetic mean. Good. Right, well. And what are the other distance-based methods we have discussed on yesterday? Uh, Good. Now also I can find 2 more participants. Very good. So this kind of interaction gives me interest to teach you more. Okay, so you should not hide anything. Whatever you know, right or wrong, you display. I tell you what is right, what or wrong, what is not. Good. So this is what we have discussed. And other than UPGMA, I asked you that the other distance-based methods. Very good. And what else? Because we'll be practicing all these methods using software tools. So minimum thing, what you have to know is the methods. Okay. Then only if I take you to the software tools, then you can understand what exactly I'm doing. Okay. Only NJ. Very good. Unweighted pair group. Okay. Still the expansion. Neighbor joining, we have seen one more. Weighted neighbor joining. Isn't it? ME. Good. ME meant for minimum evaluation. Okay. So capital M, capital E. Minimum evaluation. And FM. Again, you forgot. Pitch Margolish. Okay. Likewise, we have few more kind of distance-based methods. Now, tell me what is the output of a phylogenetic tree? Last time I didn't answer, but I have provided you the answers. What is the general name of output of phylogenetic tree? Come with answers. Again, if you see, last time I asked the same question and also explained you the types of outputs of phylogenetic tree. Uh-huh. If and if you answer, it will be easier for me to explain to the next session. What are the outputs? Name of output. You find a tree, isn't it? I have given the name of the tree for the tree. Output you will be getting. Very good. Cladogram. So generally, I mentioned you that as phylogram. I think same participant answered last time. Cladogram, tetragram, cut. I told you like phylogram is the overall thing. In phylogram, you have cladogram, phenogram. Cladogram, if you use character-based methods and construct the tree, we are using cladistics approach. If we are using cladistics approach, that is using only character based, then we call it as cladogram. The output what we get is a cladogram. If you are using phonetics approach, that is using both character and distance, this I told you as phenogram. Collectively, I told you as a phylogram. Also, we have outputs like, yes, very good. If you study the relationship between different domains and groups, dendrogram. Good. This is how I want answers from you. And we have supogram, curvogram, based on the shapes of the phylogram, how you find an output in the software. Okay. So these are some of the things we have discussed on yesterday, isn't? I mean, last session, isn't it? So now in day 11 session, now we discuss how to use the software tools for construction of phylogenetic trees. For this, first I can take you to the easiest software, that is Mega. Okay, so I've installed Mega 7 software. I think now you can able to see the Mega 7 software. Okay, in this Mega 7 software, initially, okay, can have file, analysis, help. Okay, so the font is very less in size. If you see this align, okay, I click this align here. So only I'm dictating. Okay, so first tool you can find is align here. Edit build alignment. If you click edit build alignment, you will be getting like a create a new alignment. In a create a new alignment, you have to click OK. Then it asks you that it asks like, are you building a DNA or protein sequence alignment? You remember last time I showed you how to download 5 different insulin proteins, insulin ligand proteins. In insulin ligand, I have downloaded insulin dendri, human insulin, pig insulin, bovine insulin, and another kind of an insulin. Okay, 5 different species insulin I have in FASTA format. You know, I just downloaded these 5 sequences from UniProt. I think at 2 times I have to teach you. Okay, well, first time I just downloaded 3 proteins, and the second video I downloaded 5 proteins. Okay, just like that in UniProt, you have to type insulin and you have to select 5 different species and just download FASTA. You get like this. Okay, now what exactly you're going to use that you will be giving as an input. If you give that insulin.FASTA, then you can get a tree. You have to get a tree from Mega software. Okay, are you building a DNA or a protein sequence alignment? You're going to use protein, isn't it? So click protein. After clicking protein, you get a window like this. You have Mega 7.0.18 in the background. A new window open called M7 Alignment Explorer. So here it's asking you to paste the protein sequences. So here you have to paste the sequence. For this, I'll be taking to that FASTA format already I've created. Just like that, copy all the sequences. Okay, all the 5 insulin sequences and keep somewhere here, paste. If you paste it, you get a kind of all the 5 species are pasted here. Okay, the information is given here and the sequences are pasted here. If you drag, you can see the characters in the sequence. Now you have a data like this. Okay, so in the second alignment explorer, you have one W. icon. If you keep your cursor there, align selected block by cluster W. If you want to align it, okay, you have to click this W. So W meant for cluster W. I'm going to click this. Now it's asked you to whether you're going to go for aligning the protein. Yes, I want to align protein. So click align protein. Now it gives you some default parameters. Like in sequence alignment, we have cap opening penalty, extension penalty. Okay, we have these parameters, isn't it? So these parameters or whatever present in default, you retain as such. Don't change anything. So in cluster W parameters, whatever is there in the mega software in default, use that. Okay. And I told you we have the amino acid substitution matrices like Blossom, PAM, but mega software default uses GONET. We also have amino acid substitution matrices like GONET, Identity. These are other substitution matrices. So default it uses GONET. I am not going to change anything. Even if you want to change PAM, Blossom, you can change it. Now click OK. So you have done now sequence alignment using cluster W in Mega software in that alignment explorer. Okay. Now this part is completed. So after this part, okay, you have to click data, export alignment. In export alignment, you have to export it to Nexus format. Nexus or PAUP. PAUP, no, phylogenetic analysis using parsimony. Okay, so there is a there is a software called PAUP, which uses PAUP format as the input to generate the tree. Of course, it is using a character-based software. I mean, character-based tree is constructed using this software, PAUP. So now our next step is whatever aligned in cluster W, which is in Mega software, we are converting this output in the form of a Nexus format. So for this, I'm going to click here. Okay, so I have insulin 5 proteins, isn't it? So I'm going to give like insulin proteins 5. Okay, this is the Nexus format I'm going to give. Insulin proteins underscore 5. Click save. So this is the format I have saved. Okay, you got it. What I did after the alignment, I am saving it in one specific format. After doing this specific format, okay, then you have to go for this window, Mega 7.0.18 window. Here you can see phylogeny. Okay, the icon is there. Simply click this phylogeny. Now click construct test neighbor joining tree. If you want to construct a tree using neighbor joining, click this. If you want to construct using minimum evaluation, click this. If you want to construct tree using maximum parsimony UPGMA, you can select this. Now defaultly I want to work with neighbor joining. That is, I want to construct a tree with the sequences, whatever I have. So I'm going to click here. It's asking mega format. Okay. Mega format for saving it. Okay, we can save insulin. Okay, insulin 5. I give like insulin 5. Not found. Okay, okay. So, or before that, I can do one thing. I have this sequence now. I already done that. Now I have to click align. This I have completed it. Yeah, so even you can align, I default I did with cluster W, but you can also make it through muzzle. Okay, so I've already completed this alignment. The next step, okay, is to go for analysis Before that, I just opened the file. What is the file I created? Insulin proteins underscore phi.nexus. So click open. I just opened. Now I'm going to go for analysis. Phylogeny. Construct test thing. It's again asking this. Mm, okay. I just opening this insulin 5 proteins. So now we got this kind of a window. Click compute. Okay. So now I have constructed a tree using neighbor joining method with the 5 sequences, whatever I use. So if you see this, what you can infer, pig insulin and ox insulin, okay, are closely related to each other. And human insulin is, of course, linking with pig and ox. But if you see here, okay, these two are more closely resembling, the pig and ox. So even the ox, okay, can also be used. Ox or cattle can also be used. Insulin can also be used instead of pig for human. That's what you can infer, isn't it? For the insulin ligand, you can infer like that. And we also have two other species which are somewhat distantly linked when compared to pig and bovine. So whatever you see here is the scale. 0.10 is the scale. Distance scale. Okay. So using this scale, you can infer like what is the genetic distance between one species to the another species. Here the length is less. Here the length is more. Here you can find a length is less. So this kind of a tree is generated, okay, using phonetics approach. Phonetics, it means that you are using character based and distance based. Actually, phonetics uses both character and distance. So characters, I mean number of matches. Distance is number of mismatches and gaps. Okay, if you have used a character based method, can be parsimony or likelihood. All the branches end in the same line. Okay, like all the branches have the tips of the branches, what we call as terminal nodes, are present in the same line. So just because we are using a distance-based method, that is a minimum neighbor joining method, we are getting an output like this. Got it? So now we have constructed a tree using Mega software. Okay, so Mega 7.0.18. We also have multiple tools, various tools, okay, to construct using various methods, whatever you learned. So if you see here, if you click here, you get a sequence. And if you click here, you get the aligned sequence. If you aligned using cluster W, you get that output. If you aligned using muzzle is of course another multiple sequence alignment software tool. Okay, you get that kind of an output. And if you click this icon, you get a kind of a tree, which is constructed using neighbor joining. Now we can also change the shapes. For example, if you want to see in the form of radiation, if you click here, so now this is a radiation kind of a node. If you want to see circle, so this is a circle, but this is not looking elegant. This is not fine, isn't it? Because you have less number of sequences, you don't find a significant kind of an output. So for less number of sequences, I suggest you to go for traditional. In traditional, when default we have obtained in the form of rectangular output. We can also get this kind of node, okay, angle output, or we can also get in the form of curve. This is what I told you as a curvogram. Earlier supergram, this is curvogram. Okay, so even I can see the outputs like this. And so we have also we can flip, swap, so we can do some kind of an we have options for it. If you want to provide the time, Okay, just not limiting up to using characters and distance for construction of tree. If you want to provide time, you can also provide time. That is evolutionary trees. Instead of phylogenetic trees, if you want to create an evolutionary trees, you have an option for it. You have fixed time, and generally the time tree is generally used for uh, comparing similar kind of, the ancestral species. Like for example, if you have human insulin, chimpanzee insulin, gorilla insulin, okay, these are ancestors, isn't it? So to compare that, you better you can use this time tree. Okay, we also have icons here. The left we can utilize. Okay, this is something about how to utilize the mega software for construction of phylogenetic trees. Okay, for construction of phylogenetic trees. Now I completed providing demo on Mega. Now the next software what I'm going to explain is Phylip. Phylip is Phylogeny Inference Package. So the version what we are going to use is 3.69. In 3.69, okay, Phylip 3.69, you have three folders. So this Phylip can be downloaded from the, so if you defaultly type Phylip, okay, so it takes you to this kind of University of Washington. Okay, evolution.genetics.university of Washington. So defaultly, if you click here, the either get to the GitHub, you can go to this. Okay, I'm using a older version of Phylip. So if you want to download, you can download and you can install. Okay, you have installation file also. You also have a compressed file. If you if you download the compressed file, uncompress it and use it. So likewise, I have a kind of a folder. Okay, after uncompression, you can find these three different subfolders. Okay, here you can create a lot of sequence. So if you could see this doc, okay, so we have totally 35 programs. If you want to see the 35 programs, okay, you can, if you don't know how to use the 35 programs, so for the help, just like help document, okay, you can find like this. So now initially I'm going to teach you how to use prod test. Prod test is a program used for estimating distance of proteins. If you have protein sequences, okay, like five insulin protein sequences, if you want to compute distance, initially go for prod test. After computing distance only, you can able to go for construction of trees using neighbor joining or UPGMA. If you want to construct trees, similarly, however, I mentioned you in Mega software, if you want to construct trees using Phylip, then you initially have to try with the broad-test program where initially you estimate the distance for the protein sequences. So this is a preliminary step. And the next step only you have to use neighbor. There is one program called neighbor here. Okay, so you have to use the neighbor to execute the to construct a tree. So if you want to find the help, just double click the documentation file. So now I just opened a kind of a documentation file, isn't it? So here you can see how the document, the protist file can be constructed. Initially, they are telling you, they have mentioned like uh, so initially the data set can be created like, if, for example, if you have five sequences, for the five sequences initially, you have to give for the first sequence the alpha with a tab space, they have given a sequence. And second species name, again one tab space, give one sequence. So whatever characters, amino acid sequences you provide, okay, the length of this sequence, okay, should be greater than whatever you provide here. Actually, in the first line, the 5 refers to how many species sequences you're using for comparison. If you're using 5, you have to exactly select 5. If you are using 10 sequences, you have to exactly select 10. And this number is the minimum number of sequences in comparison. For example, for the first species, if you have 15 characters, and in second, you have only 12 characters, okay, and the remaining are all 15 and above. But you in the second sequence you have 12 characters, isn't it? So you can't give more than 12. Either give 11 or 12, but don't give more than 12. If you give 12, you won't get an out. So initially, you have to give a correct kind of input to work with protest. If you get an output from protest, then only you can work with neighbor program to construct a tree using neighbor joining or even UPGMA. For UPGMA, don't have a separate program. Okay, the neighbor program is used to construct both uh, the trees using both neighbor joining method as well as UPGMA method. So if you want to learn, you can learn anyone. So initially the users can learn from the documentation. Now see the EXE. So what are the different programs you can find here? Out of 35 programs, the important programs what we are going to practice on today is protest, and then you after this you'll be practicing neighbor, NEIGH. So this is the program. I told you this program, this exe file is used to construct trees using both neighbor joining and UPGMA. Likewise, what are the other programs present? Prot pass. You understand? If you want to calculate distance from the protein sequences, you are using protest. And if you want to use a character-based method like parsimony, if you are using a parsimony method, okay, to construct a tree, use prot pass. Okay, and likewise, if you want to construct trees using maximum likelihood, use ProML. Okay, so likewise, we have for Fitch Margolish, you can use Fitch. Instead of protein sequences, if you are using DNA sequences, use DNA dist. And if you are using a maximum likelihood for DNA sequences, DNA ML, DNA pass. Likewise, we have different programs. Okay, we also have drawgram. Where is drawgram? This is the program used to construct rooted trees. For drawing unrooted trees, you use draw tree, drawgram, draw tree. So these are the programs. So you understand, for each and every method, you have different programs to work on. We also have nearly 6 fonts to see to provide the font to the trees, whatever you get. Okay, now let me explain you how to practice with the phylip. You know, this phylip .exe, okay, is present in this location. In desktop, I just copied this entire folder. In the folder, initially, you have to remember, you have to paste your sequence file. Okay, so the sequence file should be in txt format. Should be in txt format. So, but you should not take this entire pasta format for execution. I told you for protest, you have to change the format according. How to change the format? First, I'm going to click first save as. File save as. I'm going to give something like insulin 5 for this. Insulin 5.txt. Okay. The file name how I'm going to save is insulin 5.txt. Now click save. Default, if I'm not giving .txt, it means that you're saving like .txt because you are saving it as type defaultly text documents. Okay, save. So first thing you have to remember here is going to use only 5 sequences, but minimum characters you have to provide. So I'm going to provide number of characters as 15. You can give 15, you can give 14, you can give 16, whatever it is, but that should not exceed the size of sequence of what you give below. Now, the first sequence what I'm going to take is Danry. Okay, if this is the species Danry, you should not have this kind of a format. Instead of that, you should have only sequence, the amino acid sequence of a protein. So now backspace, click tab. You see, if I keep a cursor here, if I click tab, you get a tab space. How much space you have, that much space you have here. So everything should be in the same line. So now the first sequence is ready. For dietary, you have amino acid protein sequence. For the second, human, okay, you are going to paste the amino acid sequence. The third is for the pig. So whatever FASTA format you have, you are modifying the format by using the case. Now I use a pig followed by amino acid sequence. Now bovine, okay, removing the front and back text and just copying the amino acid sequence. Now last CAVPO. So I'm deleting this, okay. And remember, you should not give suscrofa because after sus you have a space suscrofa. If you give any space in between the species name, it won't work at all. And also remember, so after Dandry, give a tape space. So first I'm bringing it and now give a tab space. After human, I giving a tab space. So first bring it close and now give a tab space. So for bovine, I'm giving a tab space and CVPO giving. So all the sequences have tabs. If you remove the word wrap, I think you can better understand. Word wrap, you know? Yeah. Now you see this sequence, how it looks like. You understand? However, they have mentioned, okay? So this is the format actually. You have to save the protein sequences like this. From FASTA format to this format, I manually converted. Okay, now I converted like this. Again, I am repeating you. The 5 mean for the number of sequences you keep for comparison. If you keep 6, don't forget to keep 6 or it won't work. And again, I am telling you, for human, instead of human, if you give Homo sapiens, don't give space. And even whatever name you provide here, that should not be more than 8 characters in there. That you remember that it should be below 7 or below 7 characters. So give small names. So when I am giving human, pig, VOVN, COPN, okay. So this should be less than 7 or less than 7 characters. So simple names, and then this I told you the even this one. Okay. Now I save this. Now let us go to the TOS prompt. In TOS prompt, I go to the desired location by using CD followed by directory name. Okay, CD followed by directory name. Now I increase the font. Okay. Now the first step is that you have to take it to the exe folder. So in file 3.69, you have exe folder. You have to bring it to this location. Okay. And then you have inside this only you have prod dist program, isn't it? Type prod dist. Click enter. You get a blue screen. Now you have to input the file name. What is the file name we have typed recently? Insulin5.txt. Isn't it? Type it. Yes, it's asking like the file, out file that you wanted to use as output file already exists. Okay, do you want to replace it? Append to it. If you want to replace, type R. If you want to append, type A. If you want to create a new file, F. If you want to quit, Q. I don't want to create a new file. I want to keep the existing file. So I want to replace it. So I'm going to type R. So after typing R, you can find here, click enter. If you click enter, it takes you to this window, protein distance algorithm. It's asking like what category of model you want to select. So defaultly you have Jones Taylor Thornton matrix. So, but if you want Himura, okay. So what is the keyword you have to type under settings? Capital P. So P enter. What you got? It just jumped to the Henicoptiliar TMB, the second. But I don't want this. I want Kimura. So again type capital P and press enter. Now it skipped to the method 3, day of matrix. No, still I want Kimura. So capital P, type capital P. So see in the bottom, capital P, enter. Now check it here, Kimura formula. Likewise, even you can change the settings like substitution rates, positions, multiple data sets, whatever you want to change, you can change. But I don't want, I just want the Kimura model. So the settings right? Yes. Okay, I click Y and then enter. If it is no, you have to type capital A. Okay, capital Y and enter, you go. You have to get an output like this. If you get an output like this, then whatever you executed is right. Okay, you should also get after getting an output like this, output return to file, out file, done. Press enter to quit. So press enter, you're coming outside the blank window. CLS, clear the screen. Now come to the top. Okay, CLS for clearing the screen in TOS prompt. We have completed executing protest. I told you, if and if we complete that, then one day we can use construct the tree using any methods. I'm going to use a method called neighbor. There is a program called neighbor. This is the second program I'm using. Okay, in this method, if I want to construct a tree using UPGMA, okay, I can able to make it out. How can I make it out? First, after clicking neighbor, you get a blue screen. It's asking you to enter a file name. So what is the file name recently we have said? The input file, I mean the output file, what you generated is out file. That is the input of our neighbor program. Whatever output of protest, you have to take it as an input for neighbor. So out file is the file, isn't it? So type out file. The file out file that you wanted to use is already exists. Do you want to replace it? Happen to it. If you want to create a new file, create F. Okay, type F. Enter. Enter your new file name. Initially, I had a insulin file, and then I had now out file. If I want to have some other file like insulin 5 underscore 3. Okay, insulin 5 underscore 3. Some if you want to give to two words, use an underscore to match. If you're not using underscore, you get in trouble. I'm using two different words, but I'm using underscore in between, so it considers a single word. Okay, insulin 5 underscore 3, you get like this. Now it's asking you the first setting, what it's asking, neighbor joining UPGMA method version 3.69. Okay, neighbor joining or UPGMA. Default you have neighbor joining, but I want which method? UPGMA. If so, what I have to type? Capital N. That's what you can find as a primary key here, isn't it? The first column. So capital N, enter. See, we have a UPGMA. If I get a UPGMA, that's it. Okay, I want to freeze it out. And now I'm going to click Y to accept, enter. The file out3 that you wanted to use as output tree file already exists. It's going to create a new file that called out3. It's already exists. You want to create it or you want to replace it. If I want to replace it, capital R. You want to get a new file, you can create a file and give a file name and you can see the output in the file. Now I simply type capital R. If you want, you can try with F. Just after typing R and if I click enter, you have to get an output like this. So output written on file. So successfully written. So done. Press enter. Yes. You got an output. But where is the output? How to see the output? The output is present in out3. Okay. So where is it? It's in the folder. Check for out. Where is out? Yes, we found an out3 here. So right click, open with. Okay. Use a Windows right just once. Oh no, the tree is bad. The tree not looks fine. I do one thing. Right, how it looks. So the out file is okay. You are getting a distance matrix table. You find here how you find the distance matrix. You have 5 sequences in comparison. So first sequence, I mean in the diagonal, you have 0. And in the lower triangular matrix, whatever you have values, similarly you have values in the upper triangular. If you have 2.63, it's the 2.6. It look like an ultrametric distance matrix table is created in the outline. But the outtree is not looking good, isn't it? So I'm going to create a new file and check it out once again. Okay, let me start out once again using the neighbor. I'm going to the neighbor, type the input file, that is out file. Okay, whether you want to use already exist. Okay, replace, no problem. I want to use CPGMA, type capital N, enter. Now click Y, enter. Inappropriate memory. I better do one thing. I have to delete the file and I can try it out once again. Click the outtree. Once again, I'm trying neighbor, enter new file. Also have a file. Want to create a new file. So, okay, create a new file. Insulin file output T. Use N Y. The problem has happened. Actually, you have to start from the beginning. Okay, if you create a tree, okay, you get a tree like this. I didn't. I actually have to open the insulin file underscore tree. That's what the new file I created, isn't it? Instead of the tree, I might have tried it. Yes, I can. I already generated this file. Insulin underscore tree. Even in an insulin underscore t, you can find that file. So this is the tree constructed using UPGMA. So again, here it finds something different. Human and bovine are closely linked with each other in UPGMA. And CAVPO is closely linked with human and bovine when compared to pig. So different methods uses different outputs. That's what you can understand. In neighbor joining, it got a different output, and now in UPGMA, you're getting a different output. In neighbor joining, I tried with Mega, but UPGMA I tried with File, Protest, and Neighbor. Okay, you got it. This is how you can able to find an output. Okay, the output is generally viewed through WordPad. Okay, so initially if you try it, then if you're not getting an output, delete the input file and start doing from step 1 onwards. That is, start calculating the distance matrix from protest. Okay, this is how we have to try. So this is actually distance step out file, whatever you should. Okay, now initially I showed you now. Okay, so now I have completed providing you demo on Phylip, especially using the protest and neighbor. Okay, similarly, even you can, if you want to see the unrooted tree, you can try with raw tree. So first I clear the screen. Raw tree. It's asking for a file name. Okay, insulin. What we had? Insulin. You should not give this. I first open it. You can give. You can't give this broadest input as the input for raw tree. Instead, you have to give like FASTA format. Insulin underscore 5 proteins dot FASTA. You can check whether you have that. Insulin underscore 5 proteins dot FASTA. This is text file. I think this is the file. Yes, we have insulin underscore 5 proteins dot fasta underscore 5 proteins dot fasta unexpected enter file. So actually it's asking a .dnd file. I can also check with the rotary. So either you have to give .dnd or .txt it says. That you can check it now. Still, you have to get a DND. For DND, you have to use cluster omega. Cluster omega. So go to this cluster omega, give that input of 5 sequences dot FASTA, execute it, get a TND file. Okay, so where is it? In desktop. In desktop and from its demo, insulin underscore 5 proteins dot FASTA. Yes, this is the file, exact file. I typed and click submit. Of course, you also get a tree here in cluster W. Also, alignment is done. If you want to download output, you can download here also. Result files, input sequences, cluster format output, guide tree output, philo tree output, PIM output, submission, FASTA. Okay, you also have .dnd, a radial kind of an output, tool output. We have to check with one specific format, okay? That is input and output. It works either with Nexus or Phylogeny. So one can try that, okay? So initially I tried with .dnd, but now it's not available in the present cluster Omega. So you have to check with the formats, okay? One format will definitely support. So if you want to know how to work with the draw tree, one can look through this documentation. See the documentation, you get an idea how exactly you have to give an input. So draw programs, so they provide much information on this, so one can carefully read and you can find an answer for that. But we also have to look through the other tools. Let me explain you the other tools. The next tool what I'm going to take you is grape tree. In grape tree, so this is present in this URL, Hatchman Lab. So simply it's asking you to load files. So either paste tree FASTA format or you can type the insulin underscore 5 proteins, connect back to the end server, load files, load file, load nexus. Just pasting the nexus format. So meanwhile, you can go for the next tool, ITOL. So for radial appearance, this is the best tool I can tell you. Like if you have maximum number of sequences in comparison, which you like to get a tree from that, use an ITOL. So default you have tree of life, click to the tree of life. Okay, if you click tree of life in ITOL tool, so see, so in vertebrate kingdom, okay, so how the species are interlinked with each other. So you can get information for the bacteria, each and every bacteria, how it's linked. Okay, so you can find this in a this how we can see an excellent output for the bacteria. Okay, this is a radial tree. So likewise we have for other species, eukaryotes, archaea. Okay, now Let me go explain you how to draw the trees using the tool. For this, click upload. So choose file. So the file they ask you in the form of a specific format. Either you can give Navic format or Nexus format. Even in Mega software, you can use it to create a Navic format. Okay, so you can like how I mentioned you earlier, open Babel bin for file conversions. So for file conversions, you can use Mega software. We have Nexus format. So choose file, the Nexus, insulin underscore 5 proteins.nexus. You remember, I've done using import option. Couldn't make sure the file is an ASCII file and Navic. Better go for Navic, you won't get in trouble. So if you have a Navic, it will be fine. Can check whether you have any Navic. Fast access PDF. So for Navic, we have softwares. Still, it's loading for us. Insulin 5 proteins.nexus. Mm, I told. So I think better I can go to the Mega software. Align, red, create a new alignment, 14. Just have to paste the sequences. These are the 5 sequences. Copying it, pasting it here, have it, data, export alignment. First, I can go for even alignment using muscle. Using a muscle for multiple sequence alignment. Data, export alignment. Okay, you have only limited formats. Nexus format alone. Okay, try once again. Going to use insulin underscore 5 dot nexus. For Navic format, you can also use other softwares. Okay, it's not created yet. What is this? Data, export, nexus. Yes, see here we have insulin underscore 5 protein dot nexus. So if it couldn't make sure that is a plain text and that the tree is Navic, Nexus or Philo. So better go for Navic format. Okay, so for Navic format, so if you get a tree, okay, so obviously you can here also you can get in the form of formats where you can use it and you can save that Navic format for usage. Okay, so till now what you have understood, till now I explained you how to create. So this is the output I got on yesterday. Right with ITOL. I do better do one thing in ITOL. Better for sign in. I think even that's a problem. Initially we have registered. Okay, whatever you are going to provide your details for registration. Keep signed in. Okay, go to the sign in. So after getting sign in, okay, give a tree name. So tree name what I'm going to give here is insulin 5. Okay, so tree text, you can give a tree text or you can give a file input. Okay, whatever I tried on last time, okay, it's there in my account page. Yes, it's there. Some details are there. Okay, but my trees, if you click my trees, I already have this. Okay, this is the output I got on last time. Okay, for the 5 sequences. If you want to make it out once again, tree upload. Okay, in tree upload, select files to upload. Now I'm going to give something like insulin 5 proteins.nexus. Put it in slides, make sure the protein. So what kind of an input I've tried with student? I tried with a different format. So I better go for FASTA then. This is the FASTA file. Still I have. So the Navic alone, I can explain you. So this is the input I have taken. And this one. Yeah, this is the insulin underscore Navic. So this I got from, I just created. So the Navic format looks like this. Okay. So you can use the softwares for which it can create the Navic format. So if you create a Navic format, it is easier for you to execute. Now I just uploaded it. You got like insulin underscore Navic. If you click here, okay, so Nexus format is not supporting. So you have to create in Navic that too in text format. If you create it, then you get a kind of a tree like this. Okay, so ITOL is generally used for linking sequences, multiple sequences, that is more than 20 or 30. Okay, then you can try with this and go for radial kind of tree generation like this. Okay, so otherwise, this kind of tool is not in use. Okay, just for 2 minutes, I explained you something about bootstrapping. Now, till now, I explained you on how to use the various tools for generation of trees. Bootstrapping. What is bootstrapping? Bootstrapping is a way to check whether your tree is biologically meaningful by assessing its robustness. That is checking whether every portion of the alignment equally supports your tree. Okay. So actually bootstrapping is a multiple step process. The program starts by sampling columns in your initial alignment. Do you understand anything? So if you are not understanding anything, I can show you with an example. So if you see these trees, okay, that is here through random sampling, okay, the trees are aligned. I mean, the unrooted trees are done with bootstrapping. If you see here initially, even I have another test slide. So this is the slide I can show you for better explanation. So initial alignment, if you have sequence 1 like this, A, B, C, D, E, F, G, H, I, sequence 2, if you have like this, and sequence 3, if you have a sequence like this, initial bootstrap 1 alignment, okay, in that 9 positions, so if you see here, the sequence 1, sequence 2, sequence 3, each and every characters, each and every positions are shuffled. So, this shuffling is what we call it as a random sampling. Okay, initially you have 1, but you should get a 2 characters, isn't it? But instead, again, they give like 1. And now they bring the 8 in the third. And again, they are bringing 1. So likewise, this 9 are done in random sampling combinations. In probabilities, we just run this order, and which alignment gives you a best alignment. That's what they will be checking in bootstrapping. So bootstrapping is obviously a random sampling. If this is a bootstrap alignment 1, in second alignment, you find something different. Here you have 1, and in the second position, you won't have 1 or 2, but you have 4. And in the second, in the third thing, you have 5. So instead of 3 and 8, you have 5. So what you understand in bootstrap alignment, in all the 9 factorial combinations are done. And after the bootstrapping, you get 9 different factorial kind of trees. And which tree best fit, that software determines and tells you this is the best alignment you can do with the comparison of 3 sequences. Okay, so this is the simplest slide to explain. So whatever I told you, okay, this can be done with replacement or without replacement. If you want to replace a character and if you want to do the alignment, you can make it out. But whatever shown initially is without replacement. So I'm not replacing. I'm not changing AAC as ABC or AHC, something like that in the first position. Or if first position is AAC, even in the second, if you have one, you have AAC. You don't have other characters. So this is without replacement. You can also mutate the character. If you mutate the character, that is with replacement. Okay, bootstrapping can be done without replacement or also with replacement. So based on the probabilities, even the based on the mutation values, you're going to do the alignment and you check the best one. Got it? So bootstrapping, what you understand, obviously, I can tell you, it is used to check the tree is created is biologically meaningful by assessing its robustness. Generally use sampling, multi-step process, sampling columns are done. Okay, so here you find some columns are missing and others are duplicated. Whatever you make it out is what a bootstrap alignment. Got it? So I've completed the thing still is running here. Okay, you have to wait and you have to get a kind of an output. Okay, there are plenty of softwares to get even a with format. One can go to the softwares and convert it, and then you can work it out with what I okay initially. Okay, do you have any doubts? You can ask me. Have any doubts? Try with whatever left out. Okay, I just explained you how to work with broad, distant neighbor. You can also try with the DNA sequences. So DNA dist, and you can go for neighbor. Then it works with the DNA. Likewise, whatever left out, you can try it. Okay. If no doubts, thank you very much for your patience and interaction. Have a great day to you all.